You're going to see a lot of these in the homework. Find the equation of the plane. And then after that statement, you're going to be given enough information to find the normal vector and at least one point on the plane, okay? And that's how you want to think about it. Oh, if I want to find the equation of a plane, I need its normal vector and I need a point. And you're going to be given different kinds of information that can allow you to arrive at the normal vector and at the point. So here's an example of that. Find the equation of a plane through the points 0, 0, 1, 2, 0, 0, and 0, 3, 0. Well, what aren't you given? You are given at least one point, but what aren't you given? You're not given a normal vector. Now, there might be a faster way to do this problem, but I'm going to show you the longer way because in general, this is how you'll have to do it. There's a operation that gives us a perpendicular vector given two other vectors. What is that operation? Remember the cross product? Yeah, the cross product does that for us. So let me draw a generic picture for you that's not necessarily related to these points here. But let's say you have three vectors. Actually, you only need two vectors. Let's say you have two vectors. Say one is PQ. So I'll say that's vector PQ. And let's say you have another vector, say PR. Actually, let me draw it over here. And again, this picture is generic. It's not representative of what these points look like in relation to each other. So this picture is generic. So if you have a vector PQ, a vector PR, then what is a vector that's perpendicular to both of those?
The PR cross PQ.
Yeah, PQ cross PR. Now, it just so happens that PQ cross PR would have to point in this direction. Does everybody see why? To keep the right-hand rule in effect. It turns out that if you take PQ, PR, and PQ cross PR, they form a right-hand system, so that the vector that's first here in the cross product should be the right arm or right hand, which would be this guy, okay? So this has to be a right angle, and this has to be a right angle. Why am I doing this? Well, if you think about it, 3 points determine a plane, don't they? And we could turn those 3 points into two vectors that lie in the plane, right? Tip minus tail sort of thing. And so if we simply label this point P, this point Q, this point R, we could come up with our PQ and PR and take the cross product and come up with a normal vector and then fill in the standard form of the equation of the plane. Okay, I had a question.
Could the normal also face the negative direction?
It sure could. So you could easily take PR cross PQ, and then that vector would be the vector that points, the way I've oriented it, downward. But it would be not so much downward or upward, but perpendicular to the plane formed by PQ and PR. Yeah, and it would be just as good. You'll get the same, an equivalent equation. I won't call it the same equation, but an equivalent equation, the opposite of all the coordinates that you would get doing it the other way, or components for your normal vector. But yeah, and it's going to work. You'll get an equivalent equation. It'll work just fine. In fact, you could take any scalar multiple of PQ cross PR as your normal vector, and it just scales the equation by whatever that scalar is, and it still reduces to the same equation or an equivalent equation. Okay, so let's do this. Let's find PQ here. What would PQ be? Let's go, we would take 2 minus 0, get us 2. 0 minus 0, 0. What would the third component be? 0 minus 1, negative 1. Tip minus tail, everybody okay with that? All right, and then what would, let's do PR. PR would be what? 0 minus 0. 3 minus 0. And then 0, minus 1, negative 1. Okay, let's take that cross product. PQ cross PR. This is good review. So across the top of your pseudo-determinant IJK, in the middle, you'd put the PQ, the components of PQ. So 2, 0, negative 1. On the bottom, PR, 0, 3, negative 1. Okay? Cross out, at least in your mind, cross out that first column. What submatrix is left? 0, negative 1, 3, negative 1. That's times I. You figure out that determinant, and that'll be the I component of PQ cross PR. Okay? By definition, what operation comes next? Minus. Okay. In your mind, cross out the middle column. What submatrix is left? 2, negative 1, 0, negative 1. And then that's the J component, right? And then cross out the third column plus, cross out the third column to get the K component. 2, 0, 0, 3. Does that make sense to you? Okay. What do we get for our components? We get 0, okay, careful, 0, 0 times negative 1 is 0, minus negative 3, right? So plus 3, I. And then minus, okay, careful here. What would that be? Negative, so that'll be plus 2 when the smoke settles. And then what do we get here? For K, the K component is just 6K, so we get 3I plus 2J plus 6K. Would everybody buy that? All right. So this is a normal vector. Keep in mind, you could multiply this by anything you want, any positive constant, negative constant, and it would still work, okay? Because it'll be parallel, right? Vectors that are scalar multiples of each other are parallel, and parallel normal vectors are still normal to the plane, right? All right, so let's go ahead and find the equation. Do you think it matters which point you use for your point on the plane, the x naught, y naught, z naught? Not at all. Doesn't matter at all. So if you want to use that first point, you could think of x naught as 0, y naught as 0, z naught as 0. And then until you have it memorized, write down the standard form of the equation of the plane. Remember, it's a times x minus x naught plus b times y minus y naught plus c times z minus z naught. Don't forget the equals 0. And at this point, we're just plugging and chugging, right? So A, B, and C, components of the normal vector. X naught, y naught, z naught, those are the coordinates of your point that lies on the plane. So fill it in for me. What do we get? 3x minus 0, or just 3x, right? So just to show the work, 3 times x minus 0 plus, what's b? 2 times y minus that 0 right there, right? And then plus, what was c? 6 times the quantity z minus that 1 right there. Equals 0. Everybody agree with that? So that would be standard form, I suppose. I mean, most people would write it as 3x plus 2y plus 6 times the quantity z minus 1 equals 0 for standard form. Is everybody okay with that? And then if you wanted to write it in the general form that I mentioned earlier, just multiply everything out. You only have one thing to multiply out here and get the constant to the other side. Combine like terms, get the constant to the other side. In this case, there aren't any like terms, so you would just multiply out the 6, get 6z minus 6, I guess. So, by the way, this would be your standard form. You could stop here if you want. Standard form. And then if you wanted to write it in what I called a general form earlier, then you could go 3x plus 2y plus 6z equals 6. Do you think there's a way to check your answer? you could plug in not just one of the points, but all three of the points, right? And see if they check.